Unit 3, rigid transformations, question number 6. So question number 6 wants us to evaluate rigid versus non-rigid. So rigid transformation is something that preserves distance, okay? So rigid preserves distance, all right? So what does the word preserve mean? Well, preserve means that you keep it constant, all right? You keep it the same. So for example, salt preserves meat, okay? Because it keeps the meat from spoiling, it keeps the meat from going bad. So preserving distance means that you're keeping the distance from changing, okay? Whenever you have non-rigid, okay, so if you have non-rigid motions, non-rigid doesn't preserve distance, okay? So that means the distance will change. So it doesn't preserve distance, okay? And you're probably wondering, well, what does all of that preserve and not preserve actually mean? Well, if I want to evaluate when I change a figure or when I transform a figure, if it keeps the same distance, I need to remember the 3 ways we can evaluate distance, okay? So, or the 3 ways we can transform a figure. So the 3 ways are translation, okay, rotation, reflection, and the final one, dilation. Okay, so these are the 3 ways you can transform a figure. All right, well, you know, translation means that you're going from left to right, okay, or up and down. So left to right or up / down. Okay, rotation means that you're turning it, okay? So rotate means that I'm turning, I'm spinning, okay? Reflection means that you're flipping it across the X or the Y axis. So you're flipping it, okay? And dilation means that you're making it big or you're making it smaller. So either you're enlarging or you're shrinking, okay? So you're probably saying, well, what does that even mean? Well, whenever you translate, whenever you move either up or down, you're essentially not going to be changing distance, all right? And I'm going to show you why, okay? Say we have this circle right here, okay? And say that I choose a point on the circumference. So say I choose this point, or say I choose this point right here. Say I move up 1 unit. So if I move up 1 right here, I would move up right here once, and I would move up right here once, and I would move up right here once. From right here, right here, we'll go up once. Everywhere on the circumference, we go up once. Any solid point on the circumference, we go up once. Okay, up once, and so forth. So if I go up once, this is going to be my new circle, okay? But when I went up once, nothing essentially changed, okay? The same distance that we had between each of the different points stayed the same, all right? So a better way to look at it is if we had like a triangular figure. Say we had a triangular figure, okay? If I went left once, this is what it would look like. Left once. So it would have the same distance as it did before. So this was 1, 2, 3 units, and from here to here it's still 1, 2, 3 units. Okay? So essentially, whenever you do a left or right or up or down, it preserves distance because it has the same distance in between the points. Okay? And you can see that with coordinates. Because if we had a coordinate 4, 5, okay, and then I said I was going to move to the right 4 times. So if I move to the right 4 times, that means that I'm adding 4 to the x value. This would be 8, 5. Say I had another coordinate, alright, so say I had another coordinate, because this still had a difference of 4 units. Say I had another coordinate 6, 3, and then I move to the right 4 times, okay. So right 4 means adding 4. We would have 10, 3, which is the same distance of a 4. Okay? So the distance stays the same, or translation is rigid. Okay? Because it keeps the distance the same. So this is rigid. Well, what about rotation? Well, rotation also will be considered a rigid motion, because when I turn something, I'm turning the exact same shape. So, for example, if I look at this graphical representation right here, if I rotate it clockwise 90 degrees, all I'm doing is that I'm turning it a little bit or changing the orientation. So it would look something maybe like this. Okay? But essentially, each of the points will still have the same amount of distance from one another. Alright? So all we did is change the orientation. So rotation also is rigid because it preserves distance. Okay? Reflection is the same thing. Okay? So for example, right here we have a reflection. If I reflect, it still keeps the same distance because the figure stays the same. Okay? So again, reflection would be also rigid. The only thing that's not rigid is dilation. Alright? So, because again, if you dilate something, you're making it bigger or smaller. So think about like a rubber band. If I have a rubber band and I expand the rubber band, okay? So if I have a headband like this, for example, okay, the distance from here would be I would say from this side of the pen to this side of the pen. Alright? So what if I expanded it? What if I made it larger? So if I expanded it, so again it was from this side of the pen to right where my finger is, that's what the distance was. Okay? If I expanded it or enlarged it, would it have the same distance? No. Okay? So essentially, rigid motions do not preserve distance. It's the only thing that don't preserve distance. So it says select all the transformations that preserve distance. So the only thing that doesn't is dilation. So we would pick all the things that are not dilation. And dilation means that you're multiplying or dividing. So this preserves distance. So this is a yes. This does not, because here they're multiplying by 2. So that means that they're making it bigger. So this is a no. Alright. This means that they're multiplying by -1. But essentially, that's a rotation. And if you think about it, if we change it from the x to -1, for example, if we had a coordinate, so say we had a coordinate, for example, this coordinate right here, -7, 1. If I rotated it and changed it to x, where it stays the same as -7, and then this becomes -1, okay, it would still have the same distance regardless, okay, because again, if I changed it, alright, and said that I shifted it, I added 2, added 4, okay, so if I say I added 4 to this number, added 4 to this number, this would be -7, 5, this would be -7, +3, from -7 to 3, that's still 4 units. From 1 to 5, that's still 4 units. Okay? So regardless of if we are changing it by -1, essentially you think that it's a multiply, it will be a dilation. But in reality, it's not a dilation. This is actually a rotation. Okay? So this would still be rigid. Okay? This would not, because it would be the same as dividing by 2. So this would be not. Okay? So let's try the next one. So here's another, this is actually a rotation. I think this is a counterclockwise 90 degree. Okay, so this would be a yes. This would be a yes, that's a translation. This would be a no, because that's a dilation. This would also be a rotation, so this would also be a yes. Okay, so, oh, this is a no, sorry. This is a no. Okay. So quickly, we're gonna do the remaining one. So I'm just gonna do yeses or nos. So this is a no because that's a dilation. Yes, no, yes. This will be a yes. No, yes, no. will be a no, a no, a yes, and this will be a yes. Okay, so quickly now, go ahead and try the ones on the right side. So again, quickly go ahead and try the ones on the right side. So these are all the answers. So again, these are all the answers. You can pause the video to see all the various answers. So again, guys, just like that.